feedback is very helpful. One of the to this is that they really care about cost shocks and how they affect the market. Like within the markets, what consumers are affected, and also in some markets are impacted by cost shocks and how the competitors react to it. So these are all things that we're going to look at. We're going to have an evaluation of more capacity cost, but ultimately, as a community that created a marginal cost increase. So then this is all generally like a pass-through question that we mentioned, and consumers. But there are also some secondary questions which show that allow us to evaluate, like first capacity, or some of our people questions, and we can also think about what is the effect of the household on the competition, like on the market competition. So this relates to a much bigger literature, and this is just a really small part of it. Some of the literature has talked about pass-through in general, like Paula Navarro found that 100% pass-through. But then there was a literature on airlines in general, that was a lot of price dispersion and other things, and also the correlation literature that is mostly the structural model, and some of them have been applied to that. So this is the cost shock that I will be talking about. You might have heard about it, the grounding of the Boeing 737 MAX in the US. And this is a very exogenous shock. So then we can use experimental variation to evaluate what was the effect of the shock. So this is how like airlines have to react from one day to the other. All of their aircraft were suddenly parked because this just really happened like March 12th, that there were the crashes in Ethiopia and Malaysia, and then suddenly in all the world they were planning this aircraft circulation, including the US, which was one of the last ones. So then it's a very exciting shock in the sense. Not all the careers were affected. So you have the ones that are some careers that had 737 MAXes, and others who didn't. So you see like Southwest was very effective, and then United and American also had this aircraft model. And one important thing about this is that this aircraft model was very fuel efficient. So this is something we're going to focus on, which is going to explain why this was a marginal cost increase. Because if you think of what is marginal cost in an airline, it's not so straightforward, but it's the cost of having an additional passenger. It depends a lot on the fuel consumption. And to convince you about that, I'll show you this graph. So this is from like airlines self-reported data. So I'm not saying it's 100% reliable. They show that like 30%, around 30% of the cost of a ticket is due to fuel. So this is something that airlines care about. And we can see that also the manufacturing companies, they have been thinking about this, because as time goes by, each of the new aircraft models are getting more and more fuel efficient. And we can see here really the MAX, it's really on the end, and it is comparable to the Airbus A320neo, which is also a very fuel efficient model. But then if you check like other 737 aircrafts, which are the ones that were more available, they are much less fuel efficient. And also the A320neo, the normal A320 from Airbus is also not very fuel efficient. You can see the A320 and the neo. So just to give you an idea of what are the similar models on the Airbus. So how does the cost shock affect the career? So one thing is like, you need to think about what other capacity they have available and how fuel efficient that is. Then there was also kind of an adjustment cost of like retraining your pilots, like dealing with the shock, and like also the storage cost of the aircraft, because at the time it was really not known when this aircraft, if they could fly again. So this was something that airlines had to deal with. And so the data that we will be using, it will be covering US market, as I mentioned. We will focus on 2018 and 2019 data because we went through COVID. We will be aggregating with smaller routes, just standard things that are done in the literature. And as here you can see also the list of other carriers that were in the market. The highlighted are the ones that had 737. An important thing, so we will look at routes that were some 737 was operating at some point, and routes where it was not, they never had any 737. So this will be our definition of the treated and controlled route. And this is around 18% of the routes that had some 737 MAX, so at some point. Then I'll just tell you a bit about where the data is coming from. The fares is very standard, the DB1 that has been used in the literature in many other studies, but then we have some other data that is from OpenSky Network, which has that gives us like really high frequency data. You can really know like each each flight, when it departed, when it landed, and with what aircraft it was doing flight. And then we can also track the aircraft number that we can see and see how it's moving across time. So we can really see like all the adjustment process of the carriers. And in addition to that, we will also use the 500 domestic segment database to get the like load factors of the routes, which like shows us the frequency, like how many passengers relative to the capacity of the aircraft you're having on average on a route. So, like this is quite straightforward. We can do just like post ban period, and I already told you about what is the treated routes. They want to have 737 MAXes. So we will look at the effect on that. There's also a structural part of the paper. So first we have checked whether treated and controlled routes are similar, and we do find a lot of similarities between them in many different aspects, like distance, hub routes, you have even seen this here. The only thing we find some differences in, it's really the level of competition, but there's still a lot of variation in both. So we can also do like no parametric definition to see that this is not having no results. So then we see that the ban did not affect other, well, it affected some market outcomes and not others. It didn't not affect like the number of passengers, or remember using number of passengers as dependent variable, we don't get significance. And it also didn't affect the load factors of the routes. What it did affect was the market concentration. So we see more market concentration and less percentage of low-cost carriers after the ban. So here is just a graph of the difference in prices between treated and control group, standard. So what is interesting here is really how the aircraft, like the airlines, were adjusting to the adjustment process. And I'm just gonna give you a list of different ways that you can have adjusted, and then we think this is the most plausible from our data, that they adjusted using their idle capacity and less fuel efficient idle capacity, and hence the marginal cost increase. But you could also think like they could have used new aircrafts, they could have bought new aircrafts, or they could have changed their route structure or reduced their flight frequency. And we don't think like 2 and 3 are possible, because there is a really big lag between order and delivering of aircraft, and this is publicly available data that we can check. It takes some years, so you cannot adjust on the short term quickly. Same for the routes change, their entry and exit cost. And in other papers like Mary and Gia 2010, they are mentioning that this entry and exit occurs in the long term. So we don't think that was a channel. And also we have tried like removing routes that were exited or entered, and the results can change on the price increases. So this is not running on the top. And then we also check with the flight frequency. We don't see that treated routes are changing flight frequency relative to control. So we don't think that. This is just a regular. So as I said, what we observed is mostly that the probability to use a Boeing 737, not 77 MAX, the less fuel efficient Boeing one, is increasing, and also the probability of using an Airbus A320. So both of them are less fuel efficient, and so here are some numbers in the slide. Like one is like 14% less fuel efficient, and the other one 32. So these are quite big differences. So then this is why we're arguing that it's a marginal cost increase because we substitute to less fuel efficient capacity. So what we observe is that when we look at the main results, which would be specification 3 for the economy and specification 6 for the business class, we see that most of the effect of the shock was being translated to business consumers because they felt a 15.5% increase in prices, whereas economy only fell around like 2.6%, which is expected because the most last page should feel more after that, so it's not very surprising. And then we have also checked that how much is that relative to the average price of a flight. The average increase relative to the average price would be like 5.7 for economy, and for business it would be around 80 euros increase to the ticket price. And then if you also allow we have this treated markets, and on top of that we put another interaction to measure the additional effect of being a treated carrier in a treated market, so being one of the affected airlines in a treated market, we see that those have a higher increase in their prices. So the pass-through for affected carriers was higher, and then for the rest is probably just kind of market power effect. Then we also have checked, and I haven't shown this here for time constraints, the persistency of the shock through an event study, and we find that the effect of the shock is persistent on the 3 quarters following the map. Because that's all we have before COVID. Yeah, there's still some things that we would like to do later. So I have here some next steps, and also before, just to remind you what we've looked at. The first you already just mentioned, but we also saw that market concentration increased, and we're thinking that we want to check more about what was the total increase in fuel consumption, quantify that into money to be able to tell you the pass-through rate of the bank, and then check different route affecting, and also additional parameters. So that's everything I have for today. Thank you very much. And as I said, this is what we cover. So any comments or questions will be.
Thank you.